I love Sam Kinison in that movie. Sayed, Sayed. Someone asked which professor I am from that movie. I think if you ask Reddit, I'm a combination of Dr. Barbet and Dr. Turchison, obviously. Even though that's not true. I'm just saying that's what they would say. I don't know who you think runs garbage disposal, but I assure you it's not the Boy Scouts. Lay off Vanessa, she gives great headache. Like it's these lines that they almost just disappear in the movie. Okay. Find the absolute extreme values of this function on the interval 0, 3. So I'm going to give you another few minutes to figure this out. Be very careful. Is this function continuous? Be very careful with that. This might be all for naught. In fact, let's answer that question right now. Thomas, is it all for naught? Is this whole problem just actually one big trick because this function is not continuous? Not sure. He's going to pass it off to someone. It's too bad none of the other people who are not on camera ever like to volunteer. Or maybe there's only like usually a few of them who like to. Simran, no, because the undefined is not on the domain. Okay, so I know, so obviously Simran wasn't perfectly precise, but I know what she's talking about, right? Where is this function undefined? X equals -1, right? Because of that denominator, right? The function is not defined at x equals -1. But is -1 in the domain? No. So we don't care. This function is continuous on that domain. So our algorithm does apply. So we can go ahead and do that. So let's say 2 minutes and 45 seconds. At least get all the critical numbers. Simran and Thomas literally carrying the class. First of all, Thomas just said he was unsure. I mean, he is the only cultured one among you because he's going back to school. But what about Jaqueline? Well, Justin, and Swarnama, and Rachel, and Hirsch. Why all up in Simran's grill? Like trying to be like, they're all quiet, shy kids like you. There's not a single part of that sentence that's correct. Alrighty. Let's get this. All right, so find the critical numbers, right? Who's going to give us the fully simplified derivative so that we can work with it? F prime of x, what is it? Let's go. Fully simplified. 1 minus what? How about that?
I took the quotient rule.
Yeah. What is it?
4 over x plus 1 squared.
Good. That's all we were looking for. All right, now two types of critical numbers, right? Where does the derivative not exist? Where does the derivative equal to 0? Okay, good. So what do we get for does not exist? Where is the derivative not exist? We got the camera kids, and then we have like the 3 non-camera kids. We have Camellia, Aya, and Simran. And then everyone else, I guess, is just spectating this. D and E at -1. Jacqueline, they're all disagreeing with you.
I guess it like doesn't exist there, but it's not in the domain, so it wouldn't be like
Right.
relevant.
Yeah, exactly. Let's keep in mind what the domain is. The domain is 0 to 3, and so that gives us nothing. And where is this equal to 0? Well, let's see. If I set this whole thing equal to 0, right, I get that x plus 1 squared has to equal 4. And so that gives me what? Take the square root, I get plus or minus 2. So I get x equals -3 or x equals 1. Cool. Oh, we got Sasha and Sarah too. Nice. Sasha, do you agree with this? -3 and 1 as my two critical numbers? Sasha's typing. I thought it was just 1. Yeah, again, we have to disregard the x equals -3 because it's not in the domain, right? Just keep in mind that domain. Okay, so now we make our table of values. Okay. And what was the original function? It was x minus 4x over x plus 1, I believe. So we have 3 numbers, right? What are the 3 numbers I have to write down for my x values? And there are 3 of them. 1, 0, and 3, right? So 1 is coming from because it's a critical number, and then 0 and 3 because of endpoints. Right? You always have to check the endpoints. All right, so now substitute these back into the original function. Again, I see a lot of times some students substituting these things back into the derivative. That doesn't tell you anything. We're done with the derivative. The derivative just tells you where the critical numbers are, right? But if you actually want to know what is the largest value of the function, you need to look at the values of the function, right? Not the derivative. So substituting in 1 into this gives us what? 1 minus 4 over 2. So 1 minus 2, -1. 0 obviously just gives us 0, and 3 gives us 3 minus 12 over 4, so we get 0 again. Cool. All right, so now we just read off what is the largest and smallest, or I should say the least and the greatest elements. So the absolute maximum, actually the absolute minimum is -1, and the absolute maximum is 0.